Alright, now what we're looking at here is this is a biped. This is me taking a standard baked animation, and I'm not a character animator, so by baked animation I'm meaning I took this biped and made him automatically animate. And I used two reverse IK links to attach his hands to this rifle, so they're locked in here like this, and anything that this gun is pointing at, it doesn't matter which way it's pointing, the hands are still locked on. Okay, this is me sorting out some boilerplate issues and making sure some pipeline issues are taken care of. A friend of mine and my brother and myself, are all putting together a film short. At least I hope it ends up being short. And I put this together because we don't want to animate all of our guys shooting machine guns all the time. I basically put a particle controlled system in place to set those processes up for us. Now, this dummy object is being looked at by the gun, as you can see here, and you can see clearly there's a little bit of goofiness here. There's some interpenetration there, but that can be fixed by hand once all of the boilerplate stuff is in. And there's a script in our particle system. You'll see it's basically flying all over the place, the dummy object, that links this, there's a script that links this dummy to a particle that is tracking on our various targets over here. And that is what makes this useful, so that we can have several guys lined up in a row walking down a hill shooting at a bunch of random stuff, and we only really are going to have to worry about the one hero character who will be needing to aim at specific things, and everyone else can just kind of be on autopilot as far as I'm concerned, for the most part. Now let's cover a couple of very basic things if you want to replicate something like this. There are tutorials out there for how to attach hands to weapons, so I'm not going to cover that. But one key thing, this is all controlled through particle flow, which is Max's internal, event-driven particle system. And I'm going to cover a couple of key issues before you get started. The first issue is this is one large particle system, and when I turn it on, you'll see all kinds of stuff going on. Let me turn on the you will see all kinds of stuff going on, okay? All kinds of craziness. And the only reason this is all the craziness you're seeing is because all of our helper objects and space warps are currently turned off. These are the things that kind of make everything really go. So let's turn those off again. Let's turn off, we don't really need to see these right now because we aren't discussing these. So we're turning off the red lines there that are the target detection lines. And let's just discuss our initial things first. Let's discuss our proofs of concept in order. The first proof of concept this was for was getting our biped to aim a gun independently of his animation. Okay, we got that to work. Okay, he can aim this thing wherever he wants to. Although, not right now because all the animation is cached up now. The second thing we wanted to test with this was we wanted him walking through basically some hip-deep grass, which you see here. And I'm going to turn on wireframe so that you can see it a little bit better. And let's change our color so you can see it really well. Let's change this color to, say, more of a darker desaturated green. Okay. And down here, let's change this to a brighter green. That way it'll really pop when he's walking. As he walks, you see these things popping into existence here. Well, those are the new pieces of grass. Down here in display geometry, which I have set to geometry, I only have 10% of our grass position particles being displayed. Down here under moving grass, which is after he collides with it, it detects a collision with two you'll see these two space warps here, these two deflectors here on his feet. There are three deflectors here on his feet and one at his torso, locked in. And those are what are actually connecting with, those are what are colliding with the grass particles and with the grass particles in the grass position event, and then creating the moving grass event. And what the grass collision event does is once this collision is detected, it gives them, the grass particles, a direction away from the biped and orients them that way so that when they're animated, they're all animated in exactly the same way, but now they are given rotation in speed space, which basically means it follows whatever direction they're heading, and it rotates itself, orients itself to that. So it looks like all the grass is moving away from him. So as we pull our wireframe up again so that you can see better what's going on, you can see that it looks like, hey look, tons of grass is moving away from him. Spectacular. And because there's a collision sphere attached to both feet and the larger one to him himself, it's moving in a kind of irregular pattern. I mean, it's a regular but irregular pattern. It's not just like a boat moving through the water, but it's, you know, flopping forward a bit with each step he takes. Alright? Now at this point, I'm going to make a quick little process observation for anyone out there who wants to try doing something like this. Now, if you've worked with particles for any length of time, you know that you really want to isolate your events and work on things one at a time. You work on your gunfire, you work on your grass movement, you work on your bottle shrapnel, you work on your, right here, our muzzle flash. All of these are worked on separately, and you use a point cache right here to speed everything up so you can actually scrub through and look at it, because if you're just moving through, I'm not going to do it here, anyone who's done this even once or twice knows what I'm going to say is true, so I don't want to demonstrate it and just slow everything down. But if you're going to scrub through, you want your point cache set up. The tricky bit is, and this is kind of key, is once you have all your setups working, and they're all linked together the way you want them to be, you want a single root cache that points to everybody. You want one particle flow system driving everything. And the reason for that is if you have multiple point caches, a point cache for example, if you have a point cache for your rifle rotation and your target detection system, your grass position system, and your broken bottle initializing, your broken bottle system, what will happen is they'll all sort of overwrite each other and they'll get confused and it will go all over the place. And that's a real problem, and suddenly you're seeing a lot of unexpected behaviors. So bite the bullet, take your cache, set your memory limit up nice and high. Right here you can see that I'm still only over half of this. It starts out at 100,000 K. I have mine up at 800,000 K, but it's only using a little bit over 400,000. My update is for active segment every frame. You could do your update for you could do your sampling for every integration step, but that's just going to double your memory usage, and for the viewport there's no real use for that. But another key thing that you want to do is set your update for manually. That way, when you're doing a demonstration and you're turning your particle system off and on and off and on again, your cache stays full. If it is set to always, or the automatic setting, what will happen then is you'll turn it off and you'll clear out your cache. And then you'll have to spend several minutes waiting for the cache to fill back up again when you update it. So, let's not do that. That's just kind of me giving you hard-won advice there. So let's look through a camera. Camera 6, so we can see him going down here. We can see that we have got the fresh grass coming in as we want. We can see that we have got our targeting system is working. I want to discuss how this muzzle flash is coming in, but I also want to discuss everything in process, one step at a time as we go through. So we're going to discuss it one step at a time as we go through. We've already covered the grass, how the grass works roughly in natural language. Let's discuss how this rifle is working. Now, this rifle basically all comes down to this null object. So what we're doing here is we're setting a position, we're birthing one particle here. Okay? We're birthing one particle, and it is volume. It is in the middle of the emitter. And if we turn on our space warp so you can see them, there are several things there's several forces affecting the position of this particle here, or the particle that you cannot see. Let's see if we can't turn the particle and make it something that we can really see really well. Let's switch it to a circle. Where's that guy? Let's get all the way back here. 100%. Let's turn your particle ID on. There it is. Okay. There he is. Let's make him nice and bright so we can see him. Bright yellow. Sort of a yellowy green color. Okay. So there he is. Let's see if actually let's make him an asterisk. Let's make him an asterisk. 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 There we go. Okay. So now we can really see him a little bit better. You see he's bopping around. And what he's being attracted to is, switch to perspective view, is he's being attracted to these various gravity wells, okay, or these directional winds, and it's being pulled towards these things. I have a look at now that's basically pointing them all at this soldier, this biped down here. It's kind of getting them in closer. At one point I actually had a row of them, so it's sort of a cylinder of wind, like little wind tunnels. But I've since simplified it to what it is now. And so it runs off towards these things, gets dragged back towards a gravity that's in the middle, that's close to where it started off at, and is constantly also bouncing back off of this collision sphere here. So the particle will never get to its targeted destination. It will always just be moving close to it. The nice thing about this collision sphere, this is the volume that it's kind of targeting, and that's its miss range. You know, if it has to move further than that, the bullets aren't going to go past that. It's not going to search outside that range. And there's also a small script right here that tells this dummy object to go wherever this particle is. It tends to lag about 1 frame behind, but for our purposes that's just fine. Now let's turn on our target detection particles again so we can see them and see what's going on. Now it's sending out these things forever. It's always sending them out. If this particle is less than an 8, is greater than 1 second old, it's basically sending out 1 particle per frame. I could send out more than that. I could send out 2 or 10 or however many per frame I wanted to. And provided that my subframe sampling is working properly, then I can get nice, smooth collision detection. But this is working fine for our purposes. And these, the actual motion from these, it's being pushed out by another wind that is attached to the gun barrel here. Alright? And these are not bullets. Let me be clear about that. These are not bullets or projectiles themselves. What these are is these detect when, if you see right here, these guys right here, these detect when a shot has actually collided with the intended target, which is pretty easy to tell because you'll see the gunfire go off here, the muzzle flash go off here. They detect when there has actually been a collision with the target item. Let's get down here towards these guys. And it summons up a physics object. Now, let me take this moment to point out, or just mention, that I'm using Max 2012 for this. If you're using Max 2011 or before, you can use Reactor and Havoc and all that fun stuff. They pulled, Autodesk pulled Reactor and Havoc from 3D Studio Max for 2012 moving forward. They say it's because no one was using Havoc and Reactor, which is kind of silly because everyone I know used it, and they also have said that the people who were using it use it only 3% of the time. Well, yeah, I use the brakes in my car about 3% of the time too, but when I use them, I really like for them to be there. So, but for those of you using 2012 and after, you don't get to use Havoc and Reactor. You are using Mass Effects, which is an amazingly underpowered physics system, but it's what we're working with, and I got it to work. So that was another one of the objects of this whole exercise, was getting a system like this to work with the tools you have, because we don't know who will be my brother and I, the people who we have working on this as our core people, we don't know who will be helping us with this project later, so we want everything to work with Max out of the box as well as we can. If you have Rayfire, if you have some automatic fracturing program or plugin for Max, that's great, but don't need it. We can work with the tools we have. I'm going to take this moment to pause